Okay, before we start actually problem 3 in section 9.2, we're going to do another little review. This is just the law of sines again, and that's not that hard and not that difficult. You've worked it if you've gotten so far. This is what I usually include for the law of sines as your reference. This is just a little bit more information. And law of sines is used in these 3 situations: angle, angle, non-included side, and angle, side, side, the included side. This is the situation, and this is kind of the way I taught this when I did it in geometry, is you prove triangles are congruent by angle, angle, side, angle, 3 sides, side, angle, side. All of that works really well. But, and this is not my work, but this is what I've always used also, is SSA. If you did it the backwards, it's a bad word, and that's an ambiguous case. That would not prove a triangle congruent from back in your geometry days. And when you have it now and doing with the trig here, that's when it creates a bad situation. You will either have one triangle, two triangles, or no triangles. And let's look at those 3 scenarios. Here, one solution, this line right here. This line was constant. So wherever it hits is one triangle. 2 triangles, what happens? If that side is so long that it could hit this side if it were extended in more than one place, then you've got the 2 triangles. If this side right here is so short that it never hits this side, then it's no triangles. Okay, that's the background for this completely. And now let's go look at these problems. Okay, in this first problem, you have side-side angle. So you've got the possibility of 2 triangles, but we'll see as we go through with this one, there's really only one, but you do have 2 sides and a non-included angle. And if you'll notice, the black things are the same on both sides. Now, we're trying to determine what these 2 triangles would be. I'm first going to have to find B. So I'm looking for the possibility of 2 initially. And I go through, I've set up the law of sines. I've plugged in the values that I know. Side B is 7, side A is 9, and angle A is 30. We do the cross multiplication and division to get the sign of B by itself, but we want B, so to get B right by itself, we do inverse sine. Okay, now we have plugged that in and we get that angle, 22.89. Be sure you remember to have your calculator in degrees and not in radians. Okay, that's a definite 22.89, but there's the possibility of a second one. You must test to be sure. That could also be a reference angle for a larger angle. So 180 minus 22.89 is 157.11. Okay, now you already had a 30-degree angle that is constant in both triangles. So you want to add that 30 to the 157.11, and that gives you 187.11. That would put you over the possible 180 degrees. So that's when you decide that you only have one triangle. So once you know you have one triangle, you're going to go back and you're just going to find the other missing pieces on this side. And really, this angle right here is not just, doesn't have to have the subscript. It could just be C. Now that we know that we only have one. While we don't know, then I would keep the subscripts there. Okay, now that we know we have one and we have everything but angle C and side C, first thing we want to do is to find angle C. So the 30 we were given plus the 22.89 that we found, we subtract it from 180 and we get the 127.11. It's arithmetic if you need it. Now, the only thing missing was the side C. Okay. C corresponds to the angle 127.11. 9 was A, and its corresponding angle was 30. We'll cross multiply and then divide by the sine of 30 so that we have C by itself. Go to your calculator, perform it. If you put it in Desmos so that it looks just like this right here, it'll work every time provided you are in degrees. Side C is 14.35. And we only had what? One triangle. So we didn't have to go through the trouble of finding the second one.